Hi student, welcome to my channel EducationShop. Please subscribe my channel if you haven't subscribed yet. In this video you solve problem 1 point. In this video you solve problem 103 from chapter 3 of the book Heat and Mass Transfer by Çengel, 6th edition. Here is a statement: a 5mm diameter spherical bar. This is the spherical bar whose diameter is 5mm and its temperature is 50 centigrade. Is covered by a 1mm thick plastic insulation. This is the plastic insulation that is provided over this spherical bar and its thickness is 1mm and the thermal conductivity of this plastic is 0.13 watt per meter Kelvin. The ball is exposed to a medium at 15 centigrade. The outside temperature is T infinity 2, that is 15 centigrade, and the inside temperature here is T infinity I. This is the inside temperatures, that is 50 centigrade, with a combined convection and radiation heat transfer coefficient. The H value is 20 watt per meter square dot Kelvin. So the value of H is also given, that is 20 watt per meter square Kelvin. Determine if the plastic insulation on the bar will help or hurt heat transfer from the bar. We need to calculate whether this insulation that is provided or the spherical bar will increase the heat transfer or decrease the heat transfer. So the diameter T of the spherical ball is 5mm, then its radius R1 will be equal to di divided by 2. This is the radius, that is equal to 5 divided by 2, means to say 2.5mm, or in other word 2.5 multiply 10 to the power minus 3 meter. The combined convection and radiation heat transfer coefficient is also given, that is H, and it is 20 watt per meter square dot Kelvin. Now we will find whether this plastic insulation that is provided over this spherical ball will increase the heat transfer or decrease. Come toward its solution. The most important thing first of all is to find the outer radius. This is the radius R1 of this ball. This is the radius R2. R2 is what? R2 is equal to R1 plus the plastic thickness that is provided of this spherical ball. This is, let's say, X, and the X value is given, the thickness of the plastic, that is 1mm. 1mm means 1 multiply 10 to the power minus 3 meter. The R1 value is 2.5 and the X value is 1, that is equal to 3.5mm, or 3.5 multiply 10 to the power minus 3 meter. This is the outer radius of this spherical bar with insulation, with plastic insulation. This is the R1 value is from this point till the inner surface of this plastic, and the R2 value is from this center of the ball till the outer surface of the plastic insulation. Before deciding whether it will increase the heat transfer or decrease, we will calculate the critical radius of insulation, that is RCR, and is equal to 2K divided by H for spherical object, that is equal to 2 multiply thermal conductivity of the plastic insulation is 0.13 and the value of H, that is 20. Simply multiply and you will get the critical radius of insulation, that is 0.013, or in other word multiply with 1000, you will get 13 multiply 10 to the power minus 3, or this 10 to the power minus 3 is equal to milli. We can say that critical radius of insulation is equal to 13 millimeter and this outer radius is 3.5mm. To look at this value, if the R2 value is less than our critical radius, then it will increase the heat transfer. Let me draw its graph so you can clearly understand. The graph of the critical radius against the heat transfer is just like this. Its value is max. This is the critical radius. This is the critical radius of insulation, that is 13mm. Here the maximum heat transfer occur at the critical radius of insulation, that is Q dot maximum heat transfer from this part. Since the R2 value lies in this region, this is, let's say, R2. That's why R2 is less than our critical radius, and we can say that the heat transfer will increase until the R2 value reaches to 13mm, and then it will decreases further if it value increases beyond the critical radius of insulation. Let's say if the R2 values we got 15mm, then the heat transfers through this bar will decrease, not increase. That's the concept that the author wants to deliver you in this statement. I hope you understand. If still there is confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed. Thank you so much.